Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over limiting reagent stoichiometry or limiting reactant stoichiometry. So what is limiting reagent stoichiometry? Well, first of all, it's a type of stoichiometry problem where you run out of one substance or you run out of one reagent and you have an excess amount or leftover amount of another reagent. So one of your reactants runs out too soon before it can react completely with the other reactant. So that's a limiting reagent stoichiometry. So a limiting reagent is basically the reagent that limits how much product can be formed. So why does that one limit the reactant or limit the amount of product? Well, it's the one that runs out. So as soon as one of your reactants runs out, the reaction stops and you can't make any more product because that reactant is now gone. So it's limiting the reaction. So we call that the limiting reagent. And so therefore the other reactant can't react. And so you're left with a certain excess amount of that reactant. Okay, so then the next question you might be asking is, well, how do I know if I have a regular stoichiometry problem or a limiting reagent stoichiometry problem? Well, the hint to that is to ask yourself, how many starting values do you have? Well, if they give you one starting value, so let's say they give you the number of grams of one of your reactants, but they don't give you any information about the other reactant, or maybe they say it reacts completely with the other reactant, or the other reactant is in excess, or they say something like that. Usually you're only given one amount of the substance. In that case, you have a regular stoichiometry problem. So you just take the amount that they gave you of that one reactant and you calculate the amount of product made from that reactant. But if you are given two starting values, then you've got a limiting reagent problem. So if they're giving you the mass of one reactant and the mass of another reactant, or if they give you, say, the molarity or concentration of one reactant and they give you the concentration or molarity of another reactant, that's a limiting reagent problem. So anytime they give you the amounts of both reactants, then it's a limiting reagent problem. And you got to figure out which one of those reactants is the limiting reagent. So let's talk about key terms here. So the limiting reagent, if you haven't figured it out yet, is the chemical or the reactant that you run out of first. It's the first one to go. It's the one that's limiting the reactant because when it disappears, the reaction stops and no more product is formed. The excess reagent is the chemical or the reactant that you have left over. So that one is going to be the one that's left over. They have extra or excess amount left over. So if one of them is the limiting reagent, then the other one or other ones must be the ones that are in excess. And so when you're talking about the type of problems that you can run into when you're talking about a limiting reagent problem, they come into like three main categories. So one, the problem could be asking you to find the limiting reagent. So they give you a problem and say, okay, what's the limiting reagent? And then you got to figure out which one it is. The second type of problem is where they ask you to find how much product was formed from this combination of reactants. So in that case, you have to find the amount of product formed. And so you have to first find out what the limiting reagent is. And then from there, use the limiting reagent to find the product formed. And then third, the final category is basically where they ask you to find how much excess reagent is left over. So you figure out what the limiting reagent is, you figure out how much product is formed, and then you can also be asked to find, well, if this is how much limiting reagent you have, well, how much excess reagent is left over after the reaction is over. So those are the three main types of reactants, or I'm sorry, three main types of questions that you could be asked in a limiting reagent stoichiometry problem. Okay, so what is the key to uh, limiting reagent stoichiometry, it's all about the molar ratios. The mole ratios is what's going to be key to solving these problems and answering these sorts of questions. So let's get into that. Okay, so what is the key to stoichiometry then? As I said, it is all about mole ratios. So that balanced equation will give you the mole ratios between the two reactants. If usually there's only two, but if there's more. So if you have two reactants, you can use the mole ratio in the balanced equation to help you determine what the limiting reagent is. And so what you need to do is compare what you have with what you need. So here are the steps. So first you would convert grams of your reactants to moles. So if they're giving you grams, you got to convert it to moles, because you can only compare moles to moles when you're trying to figure out the limiting reagent and use your balanced equations, because the balanced equation, the coefficients are only a comparison of moles, not grams. So you got to convert the grams to moles. So if they give you the reactants in moles, you can skip this step. But most of the time, they're going to give you reactant amounts in grams or some other value other than moles. So your first step is to convert whatever they give you, usually grams, into moles. Next step is you want to compare with what you have to what you need in the problem. So once you've got the moles of your reactants, then you need to say, okay, do I have enough of one reactant? Do I have enough of that reactant to react with this one, or is it different than what I need, right? So there's a need amount that will react with the other reactant versus what I actually have. So what do? So one way you could do it is just compare the moles that you calculated to the mole ratio, right? So for example, if you can eyeball it pretty easily sometimes. So let's say I have, for example, my mole ratio is 1 to 2 in my equation. So let's say I have a 1 to 2 ratio in my reactants. So for every one reactant, I need double the amount of the other reactant. And let's say I do my calculation and I see, oh, I have 2.56 moles of one, right? And I have 6.03 moles of the other, right? So if I know the ratio is going to be 1 to 2, I can look at this and say, okay, so if I double the amount of this one, so this is a 1 to 2 ratio, will doubling this amount give me this, right? So if I double this, it's about 2.56, 2.5, 2.6. If I double 2.6, then doubling that will give me what, a 5.2, right? So 5.2 would be less than what I actually have given here, right? So if if I'm supposed to have double, and double of my second one of this one, double of this is, let's say it's about, it's a little bit more, it's a little bit less than 5.2. So it would be approximately 5.2. So I should have 5.2 moles of this, but what I actually have, right? This is what I have. This is what they gave me for my second reaction. This is what I need. So this is what I need to react with this many moles of A, right? Let's say like this is A and this is B, right? And this is A and this is B. This is my actual moles that they gave me. And this is my ratio for my balanced equation. You could see that for every one of A, I need double the amount of B. So for this amount of A, if I double it, I get approximately 5.2 of B that I need, right? So B, this is what I need, and this is what I have. So I have more than enough. I have extra of B, so I can see, oh, B is excess, which means that A is the limiting, right? So that is what you can do if you can eyeball it, right? But sometimes you can't. So what you would do, another way is you just convert, take the moles, say for example, A, and you can convert that into moles of B, right? So just like what I did here. So I take the moles of A that I have, and then I would convert that into the amount of B that I need, and then compare that with the B that they gave me in the problem and see, do I have more than I have? Do I have more than I need? Or do I have less than I need? And then you could figure out what the limiting reagent is. Once you have figured out, that's part 3, once you have ID'd the limiting reactant, then there's a couple of other problems that they could ask, right? So after that, they could ask you to do a stoichiometry with the limiting reagent. So they might ask you, okay, how much product can be formed from this reaction? So once you've identified the limiting reagent, you can then use that limiting reagent to do stoichiometry to calculate the amount of product formed. Or they could ask you to find the excess left over of the other reagent, right? So those are a couple of other problems they could ask you in addition to figuring out what the limiting reagent is. So they may not ask you to find the limiting reagent. They might ask you, well, how much product was formed from this reaction? And you have to know, you have to be able to identify that this problem is a limiting reagent problem. And that goes back to what I said before. If they're giving you amounts of both of your reactants, that is a limiting reagent problem. And so before you do any calculations, you need to figure out which one is the limiting reagent. Whether they ask you to do so or not, you have to figure out what the limiting reagent is. Once you figure out what the limiting reagent is, you can then go on and use that limiting reagent, use the amount of the limiting reagent that they gave you to calculate the amount of product that would be formed from that amount of limiting reagent. Okay, so that's it for this video. I hope this was helpful in clarifying what a limiting reagent stoichiometry problem is, and it helps you how to attack those problems. In another video, I will actually go over example problems of how to solve limiting reagent problems. So if you like this video, if this is helpful in any way, please hit that like button right there. Share this video with other people. Subscribe to my channel. Make sure you hit that notification bell right up there so you can be notified by other videos I put out. And put a comment down there in the comment section below. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.